Hi everybody, we are back for another day. Today we are doing parallel and perpendicular lines, which is very closely related to slope. So we're going to go ahead and get started. Let's start with definitions. Parallel and perpendicular lines are things that you've already probably heard about. We're just going to do a quick review on the vocab. Parallel lines are lines that never intersect at all. So they never cross whatsoever. That's it. Perpendicular lines are lines that intersect, but they intersect at a 90-degree angle. Now, these are if you're looking at parallel and perpendicular lines, looking doesn't necessarily mean exact. So, when you're trying to determine if lines are parallel or perpendicular to each other, just looking at it can be very deceiving because things can get very, very close to perpendicular, like 91 degrees. However, it's not exactly 90, so it's not exactly perpendicular. And things can look parallel because they're not crossing in front of your face. However, we all know, like, the arrows on the end of things can mean that they are actually it's going to continue on and they'll eventually cross. So the way that we tell for sure if something is parallel or perpendicular is actually using algebra. Okay? So that's how we're applying algebra to a little bit of geometry here. Okay? So parallel lines actually have the exact same slope. So when we talk about the equations for these lines, parallel lines have the same slope. Okay? Perpendicular lines have reciprocal slopes, meaning they get flipped upside down, and they actually have opposite signs as well. So one's going to be positive, one's going to be negative. Okay? Oh, didn't do any of this. So let's go ahead and talk about this stuff since it's already here. It was supposed to fade in, but of course it didn't. Here are a bunch of points that I made, and I relabeled these because I realized that, not that I realized, but you guys don't have color. So I'm just going to call them A, B, and C for you, and make it a little bit easier for you to understand the material as well. Now, something happened when I printed this stuff out, and somehow this one green line, just the green one, got shifted out of place. And so it's supposed to be crossing these 2 points. So we're going to pretend it does and go with it. Okay, basically I found the slopes of each of these lines because that's the only way I'm going to be able to tell if it's parallel, perpendicular, or neither. Okay, so I just did rise over run. I picked the 2 points off the line. You could have picked something different. And I just did rise over run to figure out the slopes of each one. So line A, which is this red one right here, that came out with a slope of M. No, it didn't. It came out at a slope of 1. B had a slope of -1. C also had a slope of -1. And D had a slope of 2. So going through that, looking at these slopes, I'm going to go ahead and figure out and classify which ones are parallel, which ones are perpendicular, and which ones are neither. And it's very possible that you're going to have neither more than perpendicular or parallel because there are so many numbers that don't match up or aren't reciprocal to each other. So that's probably going to be the most common thing you see. However, parallel and perpendicular do make themselves known. So make sure you know what those mean. So parallel lines have the same slope. So on this graph, line B and line C have the same slope of -1. So that means for sure those two lines are parallel. Now I'm sure when you were looking at it, it pretty much looked like they were parallel. So it was a good assumption, and we just need to check, we need to have the math to back it up. We can't just say, oh, it looks parallel, because not everyone sees the same thing. So there's a bad example because they actually are parallel. Like some people might say, oh yeah, they're definitely never going to cross. Some people might see a slight, it might look like it's kind of the yellow line or the C line is drifting towards the B line eventually. So you just want the math to back it up. But because they have the exact same slope, they're definitely for sure parallel. Then you want to go and look for the perpendicular ones. Our perpendicular have reciprocal, so flipped fractions. And remember, if you have a whole number like 2, to flip that, you would just do 2 over 1 and flip it. It becomes 1/2. Okay? And they also have opposite signs. So here, A and B are actually our perpendicular lines. Again, they probably already look perpendicular, but because you have to be very, very specific with that 90 degrees, you just want to be extra careful. So, the A had a slope of 1, B had a slope of -1. If I changed 1 into 1 over 1 and flipped it upside down, I'd still have 1 over 1, which would reduce to 1. And then I just need to change the sign of it, you get -1. So, because it's an opposite sign, and it's the reciprocal of A, B and A are perpendicular to each other. Then you just go through neither, which ones are basically not the same with each other and not opposite reciprocals with each other. Well, A and C, oh, I did it again. Those are actually perpendicular, right? Because 1 and -1. Oh, why did I do that? So, I don't think it's going to let me write it when it's in full screen. So, A and C, edit, you want to let me edit? Nope. So A and C, let's just delete it. And there we go. So here we actually have A and C are also perpendicular. I don't know why I didn't catch that. Oh, again, brain shut off. So A and C are actually perpendicular. A and B are perpendicular. A and D, they're not opposites. They're not even opposite signs, so you know for sure they're not perpendicular. And they're not the same number, so they're not parallel. So A and D are neither. Then we go on to B. B and C and are parallel. A and B are perpendicular. B and D, they are opposite signs, but they're not reciprocals of each other. One is not a reciprocal of 2, so they're not perpendicular. And again, they're not the same number, so B and D have nothing special about them. And then, let's see, C is parallel to B, but we're perpendicular to A. And again, it has nothing going on with D. So C and D are neither. And then D, we went through there. It's just nothing. It's not perpendicular or parallel to any other line. Okay? Sorry about the technical and brain fart things going on. I apologize for that. But what we have finalized here, that is the correct answer, okay? And then, here's a question. Here's an example. This is an example of things like the kind of rigor questions you will see. Okay. It says one line passes through the points 2, -3, and it also passes through -5, -1, and another line passes through the points 0, 7, and -4, 0. It's asking if these lines are perpendicular, parallel, or neither. Well, to determine that, all I need is the slope for the two. So I just went ahead and wrote out line 1 and line 2, okay, just to figure it out. How about I go back to big screen? That might help you. Get rid of this. So if I'm given 2 points and all I need is a slope, I can find that using the formula we learned in class today. So I just go ahead and do y2 minus y1 over x2 minus x1. Remember, that needs to be memorized. So I go ahead and set it up. Ooh, look, you flip. Come on. Come on. There we go. Sorry. So y2 is -1 minus y1, which is -3, all over -5 minus -2. Okay? So I go ahead and simplify this. Yay, it's working. And I get 2 on the top and -7 on the bottom. Okay? So for it to be perpendicular, it should be flipped upside down, and it should be positive. So I should get 7 over 2 for it to be perpendicular. Parallel, I'll get -2 sevenths. Neither is just when I get something completely different from either of those two. So I go ahead and do this. Oh, gosh. The flashing of the problems. So I set it up. Same thing. y2, which I picked was 0, minus y1, 7, over x2, -4, minus 0, which is my x1. That equals -7 over -4. So I go ahead and reduce this. The negatives cancel out, but I can't reduce 7 over 4. So I just get, oh gosh, 7 over 4. There we go. Which, yes, the 7 got flipped, and the sign got changed, but it's not 7 over 2, which is the reciprocal of 2 over 7. So, it's very, very close. If that 4 was just a 2, it would have been perfect, and they definitely would be perpendicular. But, because it's not, and they're not the same, this is neither. Okay? So now you're going to try this on your own, and this is basically the same thing as our example. I'm just going to do this and figure out what these slopes, and compare the two slopes that you get. And then you're also going to try this one, and it's asking which pair of equations are parallel and perpendicular. So you're going to go through and look at the slopes for each of them. Some of them you will have to get in slope-intercept form. Okay? And basically just make connections, draw lines, see which ones are actually parallel to each other, and draw lines to connect the perpendicular ones to each other. Okay? And if there's more than like one set of parallel lines, just make them separate from each other. So like this one has a slope of 3 and this one has a slope of 3. They're parallel. But this one has a slope of 2 and this one has a slope of 2. Those are also parallel. Just make them in separate lines. Okay? And then just label the lines so you know what they mean. Like write parallel on top of them. But that's it. We will go over these 2 try on your own because there are only 2 next class. And yeah, sorry about technical glitches again. Sometimes the computer likes me, sometimes it doesn't. Sometimes my brain likes me, and sometimes it doesn't. So, we'll go over this next class. Make sure you star anything you have a question on, and I will see you later. Bye, guys.